There we are. Now we're on the microphone. So let's try this one more time. There was a good response from the beginning, not so much from you guys up there. This is not church. You don't have to sit in the back. So, good morning.
Good morning.
Very good. All right, so my name is Josh Holmes, and I'm from Microsoft. I'm here to speak about web performance today. I'll be using Internet Explorer, and I'll be using all of Windows and tools from our toolkit. However, the performance techniques that I'm going to be talking about is actually it's generic. It goes across all of the major browsers. So all of the major browsers have to work in a certain way because the specs are written that way. Right? And if they don't work in the way that I'm describing today, then there's something wrong and there's something broken about the spec. So we'll be going through quite a bit of performance demo, and hopefully I don't lose too many people. So my name is Josh Holmes. Easy to find. Josh Holmes on joshholmes.com. I'm Josh Holmes on Twitter. I'm Josh Holmes on most social networks. And then SlideShare, .net/Josh Holmes. This presentation will be up, hopefully, once I have internet. Does anybody have internet? No. That's the one and only complaint that I'd have about this conference. Otherwise, it's been fantastic. One of the best conferences I've been to this year, I'll be honest. So, I've come to a zen place about the conference. It's been exciting. I have found lots of new drinks, Caparina, very good. Lots of good food. Lots of good food. Tremendous amounts of good food. I can't believe how much good food. And I've ended up meeting some of my heroes and actually getting to sit and talk to them. And other people have met good heroes. It's all good. And I found a new career. When this doesn't work, I'm going to go do this. And we're going to have lots of fun with other of my heroes. Yes, that's Robert, who spoke yesterday. Brave man. So my agenda is we're going to go through and we're going to define performance. And when we have defined performance, we're going to dive into the web runtime architecture. And I deliberately say web runtime architecture because now I'm describing the Internet Explorer runtime architecture, but as I said, all of the browsers have to use, oh, hey, they gave me a light over here. I'll move. Just because I can and nobody else has. The web runtime architecture, because all of the major browsers have roughly the same internal architecture, they may be faster at this or faster at that. They may have this optimization or that optimization, but in general, at a high level, they all work very similarly. So we're going to go through then we're going to dive into the web performance tools that I use and the Internet Explorer team uses. And then we're going to spend the rest of the time in demo. So those first three, that's about the first 10 to 20 minutes of this talk. So, all right, let's see if I can find my mouse again. There we are. All right, so quick question. How much do you know about performance? We're going to set up a little bit of an exercise here. Like a lot of the speakers, I flew in, okay? I flew in from Seattle, Washington State, 24 hours on planes. 24 hours. You realize this is a long way from Seattle? It's a very long way. So what I did is I immediately started shopping for, when my talks got accepted, I started shopping for tickets. So, I started with Priceline, and then Kayak, and then Travelocity, and then Expedia, and then Orbitz. And, comparing prices across all of these. And I noticed something. It wasn't the prices. The prices were actually fairly similar. 5 sites with theoretically the same type of activities, the same type of functionality. They've all got logos in the upper left-hand corner. They've all got banner ads. They've all got input fields, where I'm going to, where I'm going from, and how long the trip is going to be. They've all got all of those things, but some of them were zippy, very fast. Some of them, not so much. So, being a web performance guy and massively ADD, I got distracted. And I started perf tooling these instead of shopping. And so I did finally buy a ticket. However, this is the data, and I've anonymized these because I'm not here to make fun of anybody or hurt anybody. And so what I've done is I've anonymized the data, and so we've got sites 1 through 5, and we're going to go through and look at the data for each one of these. And I want, next time he goes by, I'm going to go and just stand there for, all right. So sites 1 through 5. So first thing is, you look at the total K download, right? Total download size. And some of these are very small, 1,061 kilobytes, rock on. Others are much bigger than that, 3,600, so almost a factor of 4, bigger. Then you look at the number of elements. And the number of elements, dramatic difference there from 900 all the way up to 4,200, okay? So dramatic difference in the number of elements that are created on the page. Number of CSS rules. And you look at the middle one there, number 3, and it's 1,100 CSS rules. And then you go all the way down, you go one up, and it's 5,325 CSS rules. That's a lot of CSS, okay? It's a tremendous amount of CSS. You start looking at that, and then you go to the number of image files. And again, we go from the middle one is 66 image files, and the bottom one there is 6. So wow, I mean, that's 11x. Okay, that's 11 times the number of yeah, okay, all right, good. So, and then you look at the number of JavaScript lines, okay? And the number of JavaScript lines, again, we've got a massive difference between them. So we've got 10,000 lines of code and all the way up to almost 78,000 lines of code. It's a lot of code, okay? And you look at the frameworks that they're using, and all of them are using jQuery, okay? That's just a given. All of them are jQuery. Keep calm and call on. So jQuery, some of them are using YUI, some of them are using Prototype, some of them are using XJS or Scriptaculous, some are using other smaller frameworks that I didn't list up here, but all of them are using some form of a framework plus some custom code. Okay? Does this make sense? All right, look at the numbers. So I'm going to ask you some questions here in a minute. Which site is the fastest? I'll go back here so you can review the numbers here. Which site is the fastest? Who votes for number 1? Number 2? Number 3? Handful, all right. Number 4? All right. Number 5? Okay. All right. It's number 5. So good job to you who, But a lot of people actually choose number 4 because they look at the number of lines of script. And they see that script line and they go, number of lines of script equals performance. Not so much, okay? 10,000 lines of code to almost 40,000 lines of code. I mean, there's a big difference in the lines of code, but number 5 is actually the fastest. And why? Well, if you look at it, it's in the middle to the bottom of the pack in almost every one of those categories. So it's towards the smaller on the number of K and download. It is the smallest in the number of elements. It's in the middle of the pack on the CSS rules. It's the smallest on the number of image files. Sorry, I'm sorry. So I was told to stay closer to the podium. I'm ADD. So, where was I at? Oh, and it's in the middle of the pack on number of lines of script code. But on average, it actually does decently well in all of these categories, and therefore is actually the fastest. So, now look at the numbers again. Which side is the slowest? So let's go back and we'll review the numbers again. Oh, hello. No. Hang on. Oh, the problem was backstage. Okay, fantastic. Yay. All right. Okay. Hey, my bike porn. So, all right. I lost my place again. It happens. All right. So, which side is the slowest? So we know that it's not number 5. So we're now down to 1 out of 4, okay? All right, so, oops. We'll see how fast you were. Number 1. Number 2. All right, so which side is the slowest? Number 2. Number 2 is the slowest. And again, it's not the highest in almost any category. CSS is the only category in which it's the highest. And you know that's interesting to me. It wasn't the biggest downloads. It wasn't the most number of elements. It wasn't the it didn't have the most number of files. It didn't have the most script. You know, and it wasn't using any more frameworks than the one before it. So what's the problem? Well, CSS was the only one that was big, but CSS is not necessarily bad, okay? And so what we need to do is go through and understand what actually makes websites fast, okay? And so when we're thinking about a website and front-end performance, there are 3 basic categories of things that you need to think about, okay? Number 1, network. Okay? How does somebody type in the URL, boom, to everything gets onto the computer? Okay? It has to go get it somewhere and come back. And well, here at the conference, it doesn't necessarily come back. That's okay. But at home, you know, and this is one of those funny things, you know, there's a lot of people that will go test at work, and they've got a terabyte T3 line coming into the house, and it's fast. Not when you're at home and you're on your dial-up, or does anybody use dial-up anymore? No? No? Okay, all right, good. Second category that we need to think about is the CPU, the execution. Okay, what's actually happening in the scripting and all that kind of stuff. But also, what is the website causing the browser to do? And we'll get into that here in a minute. And then the last category that a lot of people don't think about is the GPU, the graphical processing unit. This laptop here has an incredibly powerful GPU, as do most laptops, as do most desktops, as do some cell phones these days. And Internet Explorer and most of the other browsers are starting to leverage that GPU and starting to push as much of the processing to those GPUs as possible. So they're doing image decoding on the GPU, they're doing the painting and the compositing on the GPU. So they're doing a lot of work on the GPU in addition to the CPU. So we need to think about, say that fast, say that 5 times fast. GPU as well as CPU, GPU as well as CPU, GPUs. I'm wondering what the translators are doing. That's just fun. All right, so we have these three categories that we are working with. So the web runtime architecture. And again, deliberately saying not Internet Explorer architecture, but web runtime architecture. So this is roughly how we think about it, okay? Now, different browsers will have different names for the subsystems, but largely this is the way that they have to work, just because they're, well, standards-based. So we have, at the beginning, we have networking, okay? So the user types in the URL, bam, and it goes and it gets content and it brings it back, and once it's back, we start pre-processing, okay? Now, I didn't say parsing, I said pre-processing. And what we're doing is we start scrubbing through the HTML file looking for anything and everything that we can go get, okay? So we start looking for script tags. We start looking for CSS tags. We start looking for image files. We start looking for all of this stuff. And we kick off more requests to go get the additional content, okay? Now, one of the things that we have to think about there is where is your content? What content is it? And how much of it is in one place? Because one of the standard bits is that we are only allowed to open 6 concurrent connections to a single server. And this is up. It used to be 2 concurrent connections. So I could go get image 1 and image 2. And then I have to wait. And when they're downloaded, then I can go get image 3 and image 4, okay? So we're now able to do 6. However, think back to our performance data for our travel sites. One of them had 6 files. The big one had 66 files, okay? 66 files, which means that we're going to have to go back to the web server 11 times to go get that content. Or what we can do is what's called domain sharding, which is, I don't know what that translation is. Is it sharding? Do you use the word sharding? Yes? Okay, very good. All right. So domain sharding means that rather than putting all 66 images on the same server, we're actually going to put them on different servers. Because I can open up 6 connections to more than one server at a time. So if you put the 66 files spread across 11 servers, I can go get all of them at the same time. That's exciting, okay? And so this is one of the reasons to use a content delivery network. And there's a lot of great content delivery networks that are out there. The one that I'll talk about is the one with Azure, our web hosting platform, our own cloud system. And we've got a content delivery network, and one of the benefits of using these content delivery networks is that they use a tremendous number of different subdomains. And so your files can very quickly and easily be domain sharded, and you're still using one management portal, and you're not trying to upload them to a bunch of servers. You're uploading them to one place, and then you're mapping them to different CDN networks. And so that's great, and that allows allows the browser to go get more than 6 files at a time. So now, as it's going and getting that content, okay, doing the pre-processing, it goes and it gets the content and it starts bringing it down, and we start, the next bit is the parsing. We have dozens and dozens of parsers. Okay, the parsers do everything from parsing JavaScript, HTML, CSS, XHTML, SVG, variations on all those different things. There's lots of different types of content that can be parsed, okay? And so all of these are parsed, and really what the parsing engine is doing is it's creating internal data structures. And this is one that everybody should be familiar with, is the DOM tree, okay? So everybody familiar with the DOM tree? Okay, very good. If you're not familiar with the DOM tree, you're in the wrong room. The Excel user group is out the door, down the hall. So we start creating the DOM tree, and what does the DOM tree have in it? It's got elements, and it's got attributes, and it's this tree, and it's just, here's my content, okay? And then we have the CSS cascade. And the CSS cascade is we take all of the cascading style sheets and all the cascading style sheet information we find in the file, and we map that together into the cascade. Okay, so this actually gives us all of the heights and widths and depths and colors and interesting stuff. Otherwise, it's boring. It's tapioca. It's not fun. And then we have JavaScript. It's poor, lonely JavaScript, stuck down there in the JavaScript sandbox. The JavaScript sandbox is it's a security thing, right? And so in the JavaScript sandbox, that's where all the parsing of JavaScript happens. That's where the bytecode generation, any native code generation, the execution, everything happens down in the sandbox. And there are two ways that JavaScript can get out of the sandbox. The first way is through the DOM API. It can manipulate the DOM API, excitement. The second way is it can go through the network. Okay, it can make XHR requests and go through the network and download content, AJAX, etc. Then we get into formatting. Now, this is a very important step, and the reason this is an important step is that we have the DOM tree, and all of the elements and the attributes and everything in the DOM tree have no idea how big they are, what color they are, anything. They are just data. So in formatting, what we're doing is we're mapping the DOM and the CSS cascade together. Okay? And once we have that, then we go to layout. Layout is important because what layout does is it takes what's out of the formatting and puts it on the page. Okay, it decides where it's going to go and that type of thing. Formatting, at the end of the formatting, we've got a bunch of blocks. Okay, everything in HTML in CSS is a block. It's inherently so. If you've got a paragraph, it's a block. If you've got a div, it's a block. If you've got an image, it's a block. If you've got a circle on the page, well, to the browser, it's a block. It doesn't care. It's a block. And so layout, what it does, it takes all those blocks and maps them in a flow layout basis. Okay? And so layout looks at the size of the screen, looks at the DPI, looks at everything on the screen in the context, and decides, is this going to fit on the page? If not, am I going to move it down below? Am I going to shrink it? Am I going to just let it flow off the page? What's the story? So we have our layout. At the end of layout, we've done our formatting on our layout, and we now have the display tree. Okay, and the display tree, this is what's going to be drawn to the screen. Okay, now one of the things that's interesting to me is that there's not a one-to-one correlation with the DOM tree. Hey, they opened the light again. So the one-to-one correlation between the DOM is not necessarily there. And that upsets some people. There are people that don't understand that, and they get nervous and frustrated. Well, the DOM tree has elements that may or may not be displayed, because it could have a display none, right? And you could have hidden that. There could be a cascading style sheet rule that overrides something and moves it away. That's great. Formatting and layout take those out. We also might have things that are in the display tree that are not in the DOM tree. Huh? Well, an example of this is you take a ordered list, okay, and you've got your UL and your OL and your LIs and so on. Well, there's no numbers. There's no 1, 2, 3, 4 in the DOM tree. Those are added during the formatting and layout. Okay? And those are in the display tree. And once we're done with that, we're ready to paint. Now notice I said ready to paint. We're not actually painting yet. Okay? We've done all this work, and now we have to wait. And what we're waiting on is we're waiting on the hardware. We're waiting on the monitor to be ready to paint. Okay? The monitor, most modern monitors run at 60 hertz. Some run at 50, some don't. Some run at 60, some, there's different refresh rates. And what this is every second it paints 60 times. Okay? And that gives us the 60 hertz. It's great. The painting, we can't paint until the monitor is ready to paint. So we wait for that hardware interrupt to notify us that we are ready, that we can paint now. And then we paint to, in Internet Explorer, we're painting to DirectX surfaces. And then at the end of those DirectX surfaces, we're ready for our compositing, and poof, you've got a website on your screen. Excitement, excitement. Okay? That makes sense? Very good. Getting some yeses from down here. You in the back, I don't care. You sat in the back. I'm just kidding. I love you too. So we have the compositing, and then there's these other things which are input, right? So input, such as touch and hit testing, and mouse and keyboard and such, those we think of as going backwards through the funnel, okay? Because when somebody touches on the screen, boop, what it does is we have to look at the layout and formatting and see what they've actually hit. And then we have to go back into the DOM tree to see, are there any JavaScript events that are attached to this element? And then, that we have to fire. So we're working backwards through the tree, and then if we hit JavaScript and something executes and we move back, through this whole chain. We affect the DOM, we make a change, and then that affects formatting, which affects layout, which affects the display tree, and then painting and compositing, etc. What was that? Okay, so this is the web runtime architecture, okay? And so this is how you have to think about performance. And so you start thinking about things like, if I make a change to the DOM, that's going to make the browser have to redo the formatting and the layout and the display tree, et cetera. If you make a change to a CSS rule, again, you're going to have to go back through formatting and layout and so on and so forth. And you'll see where this becomes very important here very shortly. But better than being able to just create the mental model of this, what you need to do is start with a good profiler and figure out what your website is actually doing, okay? So there's two that we're going to look at very briefly. F12, the UI responsiveness tools that are built into Internet Explorer 11, and the Windows Performance Toolkit. Both of these are built on top of what we call Event Tracing for Windows, or ETW. So Event Tracing for Windows is a lightweight logging structure that is built into Windows, and all of the programs that Microsoft has written are all instrumented for ETW, but your applications can be instrumented for it as well, okay? And you can write your own plugins to read the ETW data and do performing and profiling analysis yourself as well, okay? So what we're gonna do is we'll turn on ETW, and we'll do some work, and then we'll do some analysis of that, okay? And so, let's start with the F12 developer tools and just show you a little bit about these. So, see if my mouse works up here. All right. Actually, is there an internet connection here? You know what, I'm not gonna worry about that. I'm just going to show you an offline little thing here. And what we're gonna do is this is going to be the demo that we're going to be using for the demos. This is the website. So what I'm going to do is I'm going to hit F12, and that brings up our new F12 developer tools. And with IE11, these were rewritten from the ground up. Mouse doesn't really want to work up here because it's, well, glass and it's at an angle. So I'm going to work it down here. See how that works. Kind of awkward. We'll get there. All right, so first, obviously we've got the DOM Explorer, and there's a lot of new cool stuff here, like, I can go select, a particular element. None of this is shocking. This should be fairly standard stuff. We've got an improved console, and actually the whole F12 developer tools was written by the team that does Visual Studio, and so we've got a lot of their tools built in here, and it's exciting. We've got a debugger, again, by the Visual Studio team, so it's a world-class debugger. We have a networking profiler. I like this one. I'm going to hit start, and I'm going to refresh this page. And so you can see, the different things that are, oops. There we are. So you can see the different things that were downloaded. We've got the scenario page, the HTML page, the CSS, a JavaScript background image, and the Internet Explorer logo. That's fantastic. If I hit play again, and I can go, where's it at? All browsers. And so you can see it went and got more content and brought down the other browser logos and so on and so forth. Okay? Make sense? I didn't get a yes down here, so, all right, very good, all right. So next we're gonna go to the, actually we'll skip that one, we'll come back to that one in a minute. We go to the profiler and I hit profile. So this is actually using the ETW events. And the way the ETW works is that it writes to a log and then you get to analyze it, okay? So when I get done with that, I'm gonna hit stop, and now you can see the different functions that were called, how much time we spent in each one of those functions, and so on and so forth. And that's fairly useful. So you can see, we didn't spend a whole lot of time in math down here, not actually a tremendous amount of time in draw, but left and top we're actually taking a little bit of time. Then I'm gonna go to the memory profiler and I hit play again. And so you can see it's working along there. And so it's at a constant kind of 70 meg worth of memory. And I'm going to take a heap snapshot. So that's actually going to take a snapshot of what's on my memory at the moment. And then what I'm going to do is I'm going to go increase the number of images. So I now have 144 images. We'll kick that up again to 196 images. And, oops, where's my mouse? There it is. And now I go take another heap snapshot. I'm running on battery power, so it's not all that happy. Actually, let's go ahead and put this on high performance and see what happens here. All right, so you can see that we jumped from 78 meg to 225 meg, as we're going through here. And then what we can do is we can compare these different heap snapshots, and so we can go see, what the different objects are, how big they were, in number one, number two, et cetera. So this is, I think, very, very useful to see where you're at. And then the other thing, though, that I want to take a look at is this UI responsiveness. And then we're going to open up the Windows Performance Analyzer after this, which is the F12 tool's big brother, okay? I mean, this is great. And this is quick and it's easy. The WPA is what the Windows team and the Internet Explorer team actually use themselves, and because it's incredibly powerful. Now, sometimes it's like calling in an airstrike on a playground fight. However, there are some times when that's actually what you need to go do, and so we're gonna use the WPA for the rest of this. So we're gonna analyze the collected data. Eventually. It captures a lot of data, a tremendous amount of data. And I'm going to take this back to here so that it's because I was going dizzy. So here is the, you can see that it's a lot of repetition, okay? And so what we're going to do is we're going to zoom into just this section, and then we're going to zoom into just this section. And then you can see here that we spent time in styling, okay, which is what the F12 developer tools calls formatting. And then we spent some time in rendering, okay? And then we spent some time in scripting. And then we, right here, we went to other for a little bit. Styling, rendering, scripting, okay? And so you can see this pattern repeated over and over and over again, okay? And so this is, I think, pretty cool. You can see how much time was spent in layout, how much time was spent in the timers, set interval, request interval, animation frame, etc., painting, layout, etc. And so you can see this pattern repeated over and over and over again as we're going through, okay? So I think that's kind of cool. And this is an extraordinarily useful toolkit. But again, this is the little brother to the WPA, the Windows Performance Analyzer. So let me come back over to here for a minute. And, all right, just very briefly. So the Windows Performance Analyzer, this is the big boy. I mean, this is what the Windows team and the Internet Explorer team actually use themselves to do performance analysis on their own tools as well as websites, et cetera. And so you can find this at aka.ms/performance, okay? And that'll take you to the Windows Performance Toolkit, or if you just look for Windows Performance Toolkit in your favorite search engine, you'll find it. All right. So what I've done is I've installed it in a folder called WPA, and the first thing we're going to do is I'm going to open up the Windows Performance Runtime UI, and this is the recorder specifically. And you can see here what we've done is I'm looking for HTML application analysis. If you try to profile a website and you don't turn that on, you won't get much. So it comes out rather boring. So make sure that you turn on HTML application analysis. There are other things that you can turn on. So you can go in and turn on networking I/O activity and heap usage, JavaScript snapshots, GPU activity. There's a whole bunch of stuff that we can turn on in here. But we're just going to do this bottom one here for the sake of simplicity. And then what we're going to do is we're going to set this to light detail level. And I'm going to hit start. And now I switch over to my page, and I'm going to bring up my animation, and we'll increase, and then we will close that, and we'll hit save. Okay? Type in some description. All right, and now we can open it up in the WPA. And isn't that exciting? No? No. So where it gets more exciting is when we start bringing in all these different, I really need my mouse up here. Let's see if I can get this to work one more time. So we can start bringing in things like processes. We can bring in the generic events. We can bring in, our image, window and focus, that's a very important one. We'll bring that in. So you can see here, it's actually got that's actually the Windows Performance Runtime UI. So you can see right there, Windows Performance Runtime UI. It says so right, my mouse went away. There it is. Well, whatever. So we have the Windows Performance Runtime UI, and then we switch over to Explorer, then we switch to iExplorer, and then here is another iExplorer, and this is the one where we actually did work. So I'm going to zoom in, and this is when we actually had the page up. Okay, so I'm going to go close some of these others, and you can see all the different processes that were in work there. Go down to computation, and so here is the CPU usage. So we can go grab the CPU usage sampled, CPU usage attributed, and so you can actually dig down into each one of these. And I can go turn on and off a bunch of different things. So you can see I've got Groove running, I've got ASUS stuff, but the stuff that I actually care about is this Internet Explorer bit. So I'm going to right click, I'm going to filter to that selection. Wham, okay? So I'm down to just Internet Explorer. And then if I go into that process, it's got a number of different threads. And I can go turn on the individual coloring for the different threads. And so eventually we can get to where we can see one of these threads is our parsing. And then we have JavaScript. And then we have, so each one of these threads is doing a different thing. And we're able to see how much time we spent in each one of these things. There's other things that we have, like the GPU utilization. So here's how much we were actually using the GPU. We have power information. Because one of the things that's important here is that performance is not just how fast is it, okay? Performance is also battery and all the other things that could affect the user experience, okay? Especially in today's world where we have tablets and phones and all these mobile devices that are running off of batteries, right? If you are doing things that are going to eat somebody's battery, they're going to stop using your app. Okay, so you need to think about performance broader than just how fast is it, but what is it doing to my application and so on and so forth. So there's a lot of different things that we can pull in from this. The other thing that we can do is, because we're pulling in all these different graphs, and that sounds like a lot of work, and it is. So what they've done is they have actually shipped a profile, okay, and you can set your own profile up and export it and save it off. And I'll show you how I did that in a minute. But there's a HTML application profiling profile ready to go. And so this pulls in the screens and the graphs that most people who are profiling websites actually care about. Okay? So this includes things like the window in focus, the DWM frame details, GPU utilization, CPU utilization, etc. Okay? And it's got a number of tabs here across the top, so we can do deep analysis, big picture stuff, frame analysis, thread delay analysis, and trace markers. Lots of stuff that we actually don't care about for the process of this talk. And instead, what we're going to do is we're going to go apply a lighter weight analysis that I've called Perf Doctor, because that's the name of my talk. And so this is the lightweight analysis, and we're going to spend a lot of time in this profile. And so since we're going to be spending a lot of time in this profile, what I'm going to do is I'll go to Profiles, and I will say Save Startup Profile, which means that the next time I launch the Windows Performance Analyzer, it'll just launch with these graphs ready to go, and I'm excited. So actually, you know what, now that I've shown you this, what we're going to do is we're going to go back through the demos, and I'm going to show you the deconstructing this website. So keep in mind that this is where we're going, right? And we're going to go to, this, okay? But we're not there yet. Instead, what we're going to do is we're going to start off with just the markup, okay? Now, I promise you this is actually the same website, it just doesn't have anything in it because we've disabled all the script files, we've disabled the JavaScript, and all it's doing is loading the markup itself, okay? All right, so because taking the trace and everything takes a while, what I've done is Julia Child's style. I have a couple ready to go traces. And so we're going to start with the first one. Oops. And we're going to walk through 9 of these in the next 10 to 15 minutes. So here we are. Remember we have the, we call it right here, window in focus. So Internet Explorer is the window that is in focus. And so that's the one that we care about. Once we've zoomed down to that, I'm going to close that, and we're going to start looking through this. Now, this area here seems to be the big hot activity. So I'm going to zoom into there, and you can see here's the network, okay? And so we've gone to get the o1.html itself, and then and so that's it. Okay, we've just gotten the HTML, and everything is good. And so let's go zoom into just that little bit there. Okay, and I'm going to go turn off these and turn on some of the individual components. So if I bring this out a little bit, you can see here we've got the trident bits. So we've got trident for the view, render, display, layout, and parsing. And we'll turn these on so you can actually see how much time we spent in each one of these bits. Okay? And so we go get our HTML file. Once we've got our HTML file down, okay, at the end of that, we start our, right there, it is our parsing. Right? That makes sense. Because that's, you know, if you think back to the chart, let me flip back over to the chart here real quickly. You know, here's the chart. We've got networking. We've done our networking, so now we're in parsing. We parse, great. At the end of that, we have our DOM tree, fantastic. And so the next thing that we do is we go to layout, right? But Josh, you told me that it was networking, parsing, internal data structures, formatting, then layout. Well, in this case, we don't have any formatting to do because there's no CSS information, so it's just the HTML, and so that's it. And so we're just going to take the defaults, and we go right into layout, and life is excitement, right? And so then we have to wait until there's a hardware interrupt, and at that point we go into our view render and our display. Okay, so we go into our painting and our display, and so now we have our site. And so from start to finish, so from the go to get the file to the very end, look at that there, and it is, yeah, that's what I was looking for there, roughly 19 milliseconds. Okay, does that make sense? All right, so not overly exciting, but there it is. So other things I want to point out on this one is you can see a little bit of GPU utilization here. That's actually clearing the screen. And then here is we're actually painting to the screen and we're ready to go, okay? And so you can see, you know, it took, you know, about just over 1 frame to actually download the file and paint it to the screen, okay? So that's not bad. That's pretty quick, pretty good. But it's also not a real world scenario because most of the time we have CSS and other things. So what we're going to do next is we're going to rerun this. And right here we're going to load the markup and the CSS. So same page, but it's we've loaded the markup and the CSS. And so you know, all we did there is, and we have right here the style sheet, and so it's just that, okay? That's all we've done, okay? And so now let's see how that affects our trace. Okay. So here we are. That looks to be the interesting bit of information. And I say that because I can see down here, there's the actual activity. So I'm gonna go zoom into there. And, all right, so let's turn off some of these other bits. Let's get back over to the UI thread, and we will turn on the trident bits again. So the view render, the display, layouts, post, CSS, parsing CSS, and there's our friend, formatting. And so now, if I zoom in to just this bit here, and I can go and close some of these other windows to make this a little bit easier to see. There, you can go see we have our download, and then we go get our CSS, okay? And then we go get our background image, okay? And that's all exciting. So one of the things that's interesting to me is that we have here at the beginning don't know if you can, let me see if I can zoom in just a little bit bigger. Bring that up. Right here, while we're downloading the HTML file, we have this layout, okay? And that's important because we see this in a lot of traces. And what it's actually doing is it's clearing out the display tree. It's saying, we're going to go get more content. I know that this display tree is invalid. I'll go ahead and clear that out while we're going and doing other things. Fantastic. So then the next bit is we go into parsing, and then from parsing, we go into parsing the CSS. So now we've used two different parsers, and we've created the internal data structures, and now we're parsing at the end. Then we go into layout, okay? Sorry, right there is our formatting, okay? Because it's not a whole lot of work. 5 minutes, cinco. All right, fantastic. So we go into our formatting, and then we go into our layout. And then over here on this side, now we are able to go into the view render and into the display, and we're done. At that point, we have the page loaded. And so from the beginning to the end, it didn't, there we are. So now we've got roughly 26 milliseconds. So we added about 7 milliseconds to do that part, but we're not done yet. Okay? Over here, we have more view render and display. Because what we're actually doing at this point is, well, what are we doing here? Oh, that's right, we had this big background image, okay? And so I'm gonna go from here to the end, and that whole thing is roughly 95 milliseconds. You can see there it's 95 milliseconds. And there's also this additional thread that has popped up called the HTML decoder, and I'm going to turn that on. And so now you can see all of this is image decoding. Because that background image is a couple of meg, and so it's a fairly large image. And so we had to go get that image and bring it back and decode it. And then life is good and life is exciting. But that explains this big gap here in the middle from the HTML UI thread, is that now we are pushing to the GPU and decoding that and coming back, and then we do our display. But just adding that little bit of pretty added some time. And so it's now going to take 90 to 95 milliseconds instead of 19. Okay, and so that's a fairly good sized jump. Next, we're going to go load our JavaScript. Okay, and our JavaScript, okay, all we're doing is we are coming down here and we're moving that JavaScript there. Now, why do I do that at the bottom? Anybody have any idea why I do that at the bottom? What's that? Blink effect. So if we have the JavaScript at the top, when we find JavaScript, we have to start executing. Okay? That's just the way that it is. And so by putting it at the bottom, we're able to, we do our parsing, and we get down to the bottom, and then we start doing our JavaScript. And so that's a useful thing. So all we've done is loaded the JavaScript. We actually haven't done anything with it just yet. And if we zoom in here, okay, and we'll quickly turn on and off some of these threads. So notice there's a whole lot more threads in here at this point in time, and the one that we care about, there's a couple of them in here that we care about. Let me zoom in here so that you can see that there is, hang on, there we are. So there is the a couple of different JavaScript ones, including the bytecode generation, the parsing, the source, et cetera, creating the object model, et cetera. And so there's a whole bunch more stuff, and so we've added a little bit of time. And actually, if we go from here to the very end, okay, that actually shrank in time. That's weird. Anyways, we'll have added a little bit of time for that JavaScript execution and so on. What I want to do next, though, is a very bad practice. And this is what a lot of people unfortunately do, which is I'm going to go uncomment all these things at the top here. And you may think this is contrived, but I'm going to include Modernizer and jQuery and Prototype and Scriptaculous and Backbone and Angular and MooTools and Dojo. How many people have seen this in practice? If you haven't visited a website that has all of these, I don't know what you're doing. But these are all cool, right? Yeah. So there are people that include these files just to be hip. So what we're going to do is we're going to run that, and let me go ahead and just show you what that looks like. And we've also added a whole bunch of CSS files as well, and so it looks very similar, just in the middle in black. And so we'll go ahead and close that. And did I load that already? Yes. No. Which one do I have loaded? 4 or 3. There's 4. And so we'll just show you the download times and that type of stuff. So here is you can see we're getting a bunch of extra files. Okay, so that adds time. But then, zoom in. This I found a lot of fun. Let me close some of these up here so I can show you these real quickly. And then I'm going to jump to my last demo here for sake of time. Click, click. What I find interesting here, and you can, without even diving into it, you can start seeing the problem. And the problem is that we're going from one subsystem back to another, back to another, back to another, back to another, and we're just constantly churning through that subsystem. And the reason for that is that every time we find something new, we have to go do that, and then we come back. And then we work away, and then we have to go do that, and then we come back. And then we have to go do that, and then we have to come back. And it just keeps adding and keep adding and keep adding, and we've actually added several hundred milliseconds just by including those libraries. We haven't done anything with them, we've just included them. And that's a big problem. And so now all of a sudden our download to our execution is now taking almost half a second, 0.49 seconds there, and that's a giant leap. So last demo, we go quickly to load 9, and I'm going to show you the bit here. So what we've got here is we're doing a request animation frame with 8 images, and I hit plus, and I'm going to just bump up the number of images, and you can see we're let me refresh the page here, and we'll count again. So there's 100 images, still 60 frames per second. 144 images, still 60 frames per second. 196, and we start to see a little bit of a dip. Okay. Now what we're going to do is we're just going to do a little bit of readback. And what that readback is right here, after we set the image style and width, we're just going to ask the browser a question. We're going to say, where is that image that I just talked to? And what's the browser going to say? The browser is going to say, I don't know. I don't know where it's at. Because now I need to go do the formatting and the layout and everything else all over again. And so what we're going to do is we'll save that, and you'll see this one here. So we're going to run, and I show you here's the readback, and you can see we already have significant issues with 64 images. Okay, we're at 30 frames a second with 64 images. If we try to get up to, so all we've done is ask the browser a question. And whoops. And so let me just very quickly show you this. And I'm just going to zoom into any small portion of this. Zoom in. Actually, we'll just leave it there, and I'm going to go turn off these 2 threads and very quickly turn on these. And so you can see we're spending a tremendous amount of time there in layout. and then we go to our display, and then we go to our JavaScript, and then we go to formatting, but you can see all the time that we're spending in layout. And what that's doing is every time we touch an element and ask it a question, the browser has to go back and redo the formatting of the layout and everything else. And that is a very significant problem. And there's ways that you can very quickly figure out what is going on. So let me just show you F12. Go to the, where are we at? Here's the profiler. I hit start. I hit stop. And you can see there, we're spending a lot of time in offset width. Tremendous amount of time spent in offset width. So it's very, very quick and easy to go identify, oh, that's what's causing that, that problem and causing all that time. All right, so with that, let me get out of here. And I think I have run into your coffee break a little bit. I apologize for that. So where's IE 11 now? It's in dev preview on Windows 8.1 and available on Windows 7. I will warn you, the Perf tools are not there yet. In Windows 7, they are coming. It's between us, me and 1,000 of my favorite friends. Lots of new tools, the F12 developer tools that you saw. There is a new user agent string. You should look at that. WebGL is awesome. It's badass. I love it. Evergreen updates. It's going to automatically update everybody and keep them on the latest browser. You have to opt out of that, which is good. Unfortunately, there will be companies who opt out. More standards, more GPU, more awesome sauce. I am excited about that. For more information, go to modern.ie. There you can scan your URL. If you just type in your URL, it will go scan for common problems across a number of different browsers. We also have a lot of tools such as free access to Browser Stack, so that you can do cross-platform, cross-browser testing. We have offers for cheap parallels. We have free virtual machines. We've got Sauce Labs integration. We've got a lot of great stuff up there. Last thing I'll mention is we also have a community of people who are active and engaged with us around Internet Explorer. They are giving us feedback about Internet Explorer, and they also, since they're third parties, they can answer very honestly questions from the community about Internet Explorer and about how to work with it and use it. They can say things that I can't. So reach out to these guys, useragents.ie. If you're interested in becoming a user agent, let me know. And you can contact me. Oh, and sorry, and the user agents, these include people like the president of the jQuery Foundation, lots of the guys from Ubuntu. We've got a tremendous number of great guys around the world that are included in this community. And lastly, I just want to say thank you very much to these guys. Feel free to reach out. No time for questions, right?
Yeah, no time.
No time. Find me. I'll be out in the lobby. Thank you.
Thank you very much. Thank you very much.